Anyway, I think it's funny. I have often used this Lucy as my front title slide, and it feels even more relevant today with the pandemic. And I think that all of us need a mental health check-in. We're all struggling, but it's part of also what inspires me that there are people out there, people more empathetic than Lucy, and we're all there for each other. And I think those kind of check-ins are what's kind of keeping I'm an optimistic person, and it's keeping my optimism alive. Interesting. Okay, there we go. I wanted to talk a little bit about Le Corbusier because I think this quote is really inspirational, and I find it helps me think about the challenges of today with positivity and drive. He prophesies this kind of whole new age of design, which requires us to focus on rigorously defining our problems rather than simply seeking solutions. Actually, interesting, Marcus. It felt like that's what you were speaking about. He articulates how understanding our goals and defining the impediments to those goals will lead us directly towards solutions. And I find that really a great way of thinking about how we should approach this current situation and also in general on any day-to-day. And that's what I'm here to talk to you about, using design principles to envision the future. As Nikki said, I'm based in the Bay Area. Sunrise over the Golden Gate Bridge is one of the most beautiful things we can all see. And not now, of course, because we can't travel. But there are so many scary obstacles in our way, and it seems like new ones are arising every day, whether it's climate change or the abuses of big data, and, which seems so quaint now. What we had been thinking about a lot before was the robot apocalypse. And honestly, I'm still fairly optimistic. I think that our ability to work together to make a better world has never been stronger. And part of the reason that I think I can continue to be so optimistic is I get to work at Autodesk. It's a company whose vision it is to develop tools to help people really imagine, design, and create a better world. In brief, if you've ever admired a towering skyscraper or driven a high-performance automobile or watched a great film, chances are you've experienced what millions of Autodesk customers are doing with our software. We help customers design and make everything. We help our customers make cars and buildings that have less environmental impact and movies that have more emotional impact. Our tools automate how things are designed in the digital world and also how they're made in the physical one. I'm only telling you this to kind of give you an introduction to who we are and what I'm passionate about, and that's helping anyone make anything. It's really a gift. I mean, it's even more so of late to be able to work somewhere that so closely aligns with my personal values and where the future is imbued with a real sense of optimism for what we can make together. So that's my way of introduction to Autodesk. For centuries, fuel has acted as an accelerant for how we make our ideas real. Coal accelerated our ideas for how the handmade could become the machine-made, and thus kicked off the industrial age. Then came the age of steam and steel, and then from here we made our ideas for telegraph and railway networks, gas, water supply, electrical power, telephones. We took our first little baby steps into this connected technological world. And this connected age, and the fuel for that connected age has been oil. It sparked an unprecedented boom. The industry grew so fast that regulators scrambled to control its rapid growth. Does this sound familiar, right? A fight over a valuable new commodity, fast, underregulated growth. If it does, it's because we've developed a new fuel for ideas, data. Data is the new commodity being fought over. And without taking the metaphor too far, the cloud is its pipeline. Data is the fuel that drives 5 of the biggest companies in the world, all of them cloud companies. For Google, Amazon, Facebook, Apple, Microsoft, the cloud is the new baseline. And it's the cloud that's transforming the way all of us are living our lives. The way we travel, when we travel, the way we relax, the way we communicate, and now in the midst of this global pandemic, the effects and the benefits of the cloud are even more important than ever. Software is playing a new role in the world, and the world of design is undergoing the same transformation. The cloud is already transforming the way we all design and make things. It's transformed from a nice to have into an imperative. Your designs can no longer be confined inside the little static boxes that live on top of your or underneath your desk, or in my case now, the dining room table. No longer do we rely on equally static representations of all the things that we're making. And no longer do your products have to remain static as you send them out into the world for customers to use. Your products now are permanently connected. I can't now remember her name, and you're not up in my video feed of the person who was talking about the connection of all the heaters and the lighting and everything in our home. But now that everything's connected, it can live and grow out in the world. And so too can all the cloud tools that we use. Cloud products are never shipped and never finished. They're continually iterated. And the tools available are no different. No longer do we push out finished tools. The tools that we use today and what you would expect from them are undergoing a metamorphosis as well. I think Nikki said he was going to talk about the chair. I want to talk a little bit about generative design. It's a little bit threatening to think about how our tools are going to be working with us in tandem. The idea of the big data and the potential for its abuse is real. And we're, as a company, envisioning how the design tools are being transformed by abundant and fairly inexpensive compute power. When computation was finite, we made tools like this mouse, right? They were directed. We had an idea, we put in the mouse, we designed it on the computer. You directed the tool. You decided when to run a simulation on a design to discover its performance. But now computation is so abundant and so relatively inexpensive that we can flip the entire thing around. No longer simulating based on a design, and no longer simulating during design, but simulating in order to discover the design. As I was talking about Le Corbusier, as he presaged, with generative design, you need to just describe the problem, the goals, the constraints, the forces at play, and the tools helps you discover what is possible. It uses abundant compute power to analyze the entire solution space. Discovering designs you would never have come up with on your own. This chair, in fact, has become part, it's one of the first generally designed chairs and was designed at Autodesk and is now part of the permanent collection at San Francisco Museum of Modern Art. Because generative design is helping us move beyond just synthesizing geometry. It's starting to understand something infinitely more complex, and that's us, people. A couple years ago, we moved into a new building in Toronto, and we decided to, this is the Autodesk headquarters in Toronto, we're just part of it, and we used it as a living experiment. We had an experiment to discover how we could maximize productivity, create a great working environment for the people working there. There's about 50 employees in Toronto. So we used generative design, and we fed it the forces influencing human productivity. Right? We surveyed the employees, we captured their preferences, we wanted to create extra light, the greatest access to outdoor space, but we still had the hard constraints. I mean, the building's the building, and the bathrooms are where the bathrooms are, the kitchens are where the kitchens are. So how do we come up with what is the best environment for the Autodesk employees who are working there? And we found an equitable solution by thinking about taking all these ideas into consideration, not just coming up with one solution, but coming up with hundreds and not thousands of solutions. And then we could all work together and take that information and figure out what would work best. So in tandem with the ideas that the computer fed us, we were able to come up with a solution that worked for the employees that work there. And we found this equitable solution and built it out. Traditional tools passively waited for our instructions, like the mouse. And the relationship was purely directive. We directed the tool, but the relationship has really evolved into one that's adaptive. Our generative design tools anticipate our needs, and in doing so, they help us discover the best designs possible. It's a new paradigm for applying almost infinite computing power in the service of human desire. And how about creating the things that we design? We look at how the way that we make things is being transformed by abundant compute power. I've been talking about that. And I'd like to present a positive view of how robots and humans will work together rather than just our current trend to fear this whole robotic apocalypse. So in the initial conversation, I was talking about kind of how compute power on the computer is doing this, but this is also evolves into robots, because again, we're talking about the connected power of how things work together. I think we're all afraid of automation stealing our jobs. And the physical capability of robots really hasn't changed that much in decades, nor has their environment. We tend to lock our robots in the same little spaces, and it's frankly a great idea that we do that because robots are dangerous. They weigh a ton and they have no vision. They can't see where we are or if we're in the way. But as a result of locking down where the robots are, we also lock down our whole process and the way that we're protecting our investment of those robots. Since the 1980s, we've been following a disciplined, data-driven approach to streamlining manufacturing, making it lean, making it efficient, and our processes have become rigidly locked down in that idea. And we balance the economic equation with volume. But now, really with the power of the cloud and computing and robotics, we can flip this economic equation on its head. I'm going to give you an example of how that could be done. This is a robot called Ash, and she's the same as any other robot, industrial robot, but we don't keep her locked in a cell. We're exploring how we can give Ash the freedom to 3D print in metal, all on her own. And she doesn't rely on us for the direction. Instead, she works as part of a closed-loop system to self-correct as she prints. And as we build more capabilities into Ash, so we need to build more flexibility into the way we work with her. So we brought her into a full-scale, real-time VR environment, and we can step into her world and appreciate a closer relationship with her. We can interact with her intuitively, and we can use her arms, or our arms, to manipulate her arm. She only has one. Which means that the space she occupies is no longer a barrier as it was in traditional manufacturing processes. The way we work with robots no longer has to be so rigid thanks to virtual reality. And by giving the robot new capabilities, the way robots work with us becomes more fluid. Abundant computing is transforming the tools we use to design and make things. In turn, the very things we make are also being transformed by these tools. This chair form embodies evolutionary algorithms of generative design. And these floor plans show how far beyond our limitation these tools can take us. And this wheel, I thought somebody said they were a gearhead. This wheel design reveals what's possible when we let go of our tool and let it direct us. When we directed our tools, we described our idea for a design. So we already had an idea of how the forces would flow through it. The chair and the floor plan are both static, but we've also been experimenting with generative design on something like this wheel, which is a moving system, right? We have to think about the forces in the road, how this is going to move, and how it might fail. And it made it that much harder because now, though we can hold this wheel in our hands, it becomes much harder as a concept to do in our head. This is not something we could have designed our own. It becomes much more, it's inspectable, but it becomes much more inscrutable. Data is increasingly driving our design decisions, and as we capture increasing amounts of data, our traditional tools can't scale, and neither can we. But now we can tackle ever bigger problems because of two things. And I've talked, I keep repeating this, but it's a Zoom talk, so it's helpful. The capability of modern machine learning has really transformed how we work and the massive parallelism of computing systems that they're running on. When it comes to configuring the system architectures for machine learning itself can already do better than we can at a number of different things. I think a good example of machine learning for people who are not in this industry is Google Translate. A lot of you seem to be from abroad, so I'm sure that you've used this tool. We use it directly. It used to, the way it worked, it would directly translate from one language into another. It would take a phrase, where's the store? How do I buy a loaf of bread? How do I buy a train ticket? And it would exactly translate that phrase. Which explains how some of the results kind of look like this. And they didn't quite read well. But then they changed the architecture of Google Translate and they subjected it to machine learning. And it yields a totally different result. one which can absorb meaning from any language and re-express that meaning in any other language. It preserves so much more of the nuance of our language, but there's also a downside because we don't know how it works. Very few of us understand what's happening behind the scenes within the computer and in the machine learning algorithm. It escapes our comprehension. It might be said even that Google Translate understands us better than we understand ourselves, and that's scary. Our tools and the way that we make them are turning into black boxes. But just because they're black boxes that are less inspectable doesn't make them any less trustworthy. It's a scary concept to embrace, but I think one that we all are embracing every day. These black boxes can be more reliable than their over-engineered predecessors, more reliable than we are, in fact, at facial recognition, at cancer detection, and at driving. Self-driving cars aren't built on that conditional if-then. They're built on insights. They don't run on formulas and functions. They are predictive, projective, and productive. Machine learning focuses on the principle of driving, not the formula of driving. If-then statements are like our rear view mirror. We have these autonomous systems that look forward and out into the world, and we learn from what they're out there. We build the computational model at first on the conditional, but from this is emerging one engineered to be insightful, so that our future tools look like transformed by machine learning. What do we think they're going to, what's going to come out of them? It may be a long time before self-driving everything, before we have self-driving everything, but what do the first steps look like? I'm going to go back to robotics and talk a little bit about how we can build data-driven solutions for eliminating defects that aren't so linear. This is Madeline Gannon, and she's a computer vision specialist. And she helped give robots computer vision. She now works at NVIDIA. We give them the ability to see, so no longer are they blind to our presence. And by applying machine learning, we give them the ability to learn, so no longer they are blind to our presence. And by applying, and rather than requiring this conformed kind of assembly line where we stick the robots, our robots can learn to accommodate the variability of our disorderly human world. Let me show you what I mean. This is another computer also in our robot lab in San Francisco, where I have not been since February. We introduced this robot, Bishop, to the disorderly world of Lego. We built a machine with curiosity and intelligence so that its intelligence could evolve. Bishop came to understand that he has eyes to see and a hand to grasp. Of course, I'm anthropomorphizing these structures, but it gives you an idea of how much power we've been able to put into the hand of a computer. And Bishop evolved a basic ability to react and respond to his environment. Then we accelerated his development by creating an artificial world for him to learn in. We replaced what he sees by creating a digital, physical simulation of Lego bricks that correspond to the real world. Because we understand that a Lego brick is a Lego brick, but a computer vision just sees the form, right? And if it's sideways, that's another view. To us, we have that 3D vision that we can see that naturally. And the goal of learning how to assemble the pieces, oh, sorry, the animation didn't start. Let me see if I can go back. Interesting, it's not running. Sorry about that. Oh, there we go. I was like, it's not happening. It should be moving. So the goal of learning to assemble the pieces, we fed him a neural net and the view of what he would see. And we decoupled the learning environment from Bishop's physical environment. And we also decoupled time. And the computer could now learn in computer time, grabbing assembly in millions of blocks overnight. to figure out what the right solution would be. And we can replace those Lego blocks with anything. So the robot can learn to grasp and assemble any object in any part. And if any part comes out of order, it no longer does the robot stop and wait until things are back in order. They're able now to continue the process because we've created this closed loop system. And the amazing thing about the cloud is once this robot has learned how to do it, all robots have learned it. So rather than relying on conformity, we can embrace variability. Just as we need to let go of the wheel to fully realize the promise of self-driving vehicles, we also need to let go of our traditional tools. Only then will we realize their full potential. In the past, and also, frankly, in the present, computation has remained finite and limited to this box on our desk. And in this world, we would exhibit these rigid characteristics here that you see on the left, kind of this, maybe it's your right, of how you get stuck in these rigid ways of thinking about the world. So imagine instead a parallel world where computation is abundant and data becomes the fuel. It's a transformation that's leading to the adoption of a more fluid and creative characteristics. And what is emerging from this transformation is something greater than the sum of all these parts. These new tools are capable of representing and comprehending what we design and our ideas, and the means of giving these ideas agency and embodiment. Now that we've defined the problem space, we're able to let go of the tools and have the tool come to us. And in doing so, we find that our tools are still as logical and analytical as ever, but now they're also creative and intuitive. At Autodesk, where I have the pleasure to work, now virtually, we are designing these tools and imbuing them with the qualities of a true design partner. A partner which is not just good at execution, but excels at exploration. Just imagine how much further we can go when we partner our human innovation with automation. Together, we can bring out the best in each other and become your partner for the new possible. Together, we can make anything. Thank you.
Nice, wonderful. Thank you so much for this amazing presentation. Kat has a real life heart. Love that one.
Aw, thank you, Kat. It's funny, I'm not supposed to talk about politics, but I was joking that Biden should just have a little liar sign like that, exactly like that, and during the debate just be like, lie, because he can't interrupt him at every sentence, but it might be helpful.
Not checking in real time.
Yeah, exactly, that's exactly right. It's like Mystery Science Theater. So I don't know, Nikki, what the process you want to do.
It up.
If people have questions for me about Autodesk or how we're thinking about the future or partnering for the new possible, I'm happy to answer any questions that you have.
Rama, Autodesk isn't a great name for it anymore, is it?
No, it's a terrible name. You know, it's funny, when I interviewed at Autodesk, I've been here now 12 years, and I interviewed with the VP of comms at the time, and she said, you know, you've looked into our company and now you have a better sense of it. Is there anything that you think that we should do differently? And I said this in my interview. And I was like, change the company name. Here's the thing. I agree that there's something that maybe that it's not the best company name, but the bottom line is that I don't think people associate Autodesk, people who know Autodesk certainly don't associate it with an automatic desk or an automated desk, right? And so I think what's happened is the name has transcended the original meaning of the name and is now just the name of a reliable and trusted company that has outlasted through innovation and hard work a lot of Silicon Valley companies that started around the same time.
You're just making excuses. You know it's a shitty name. You're just trying to justify it.
That's for Marcus, not for me, Kat. No, I mean, I think maybe, but I do think that there is something to saying so many, you know, so many of the companies in Silicon Valley that started that people thought could never go away, right? That were have gone away. And I think one of the things about Autodesk is that it's ironic, because a lot of the work that we do is in construction and building. And I think that we've built a company, and keeping to that tradition of the name of the company has some kind of importance to say that not everything is just the future looking ahead and everything's new and everything else, but we're built on a foundation. And that foundation is associated with this name, which, yes, if I was naming something today, it'd be some stupid sans serif, word that's in everyday use that's changed. But just like, Google, I think most kids today don't know what Googleplex is, and they just associate it, and it's become a verb. I think Autodesk kind of has
okay,
that.
I'm teasing you.
I'll take it. I'm going to be very serious. These are serious times.
Look, I'm in London. We're used to this.
Despite the fact
But it is a strange name.
I'm unemployable. I would never fit in an organization. It would never work to put me in an organizational structure. Having said all of this, if you put a gun on my head and you said you have to work at an organization and you can choose, at least I choose Autodesk to work for. I think it's not only in the products, what you're doing is amazing, but also every single individual that I've met at Autodesk is an amazing personality. Would you also share a little about the people, the work, the working culture?
It's work environment's funny because it has been so different, but I have to say I had never worked for such a large company. I grew up in a really lefty liberal family. Not quite before I started working at Autodesk, but pretty recent to working at Autodesk. I thought a public company was a company that was owned by the government. It was public, like public school, and I know it's different in England, and a private company was owned by a private individual. Like, I never considered myself as somebody who would work for a multinational company. But really, it's just such from my perspective, working there for 12 years, it's a company that really cares. And it's not a bullshit line that we want to make the world a better place, and really we just want to sell more advertising. We understand the tremendous responsibility that we hold because our tools are literally designing almost everything, right? So whether that's the computer that I'm talking to you on, or the car that I now drive once every couple weeks, or even my toothbrush, right? So, and then movies that I watch. So we understand that we have a responsibility because we're making the tools that are making the world. And we need to think about efficiency. We need to think about sustainability. We need to think about our impact on the world and think about making the world better. And any step that we can take to do that, whether or not we always succeed, that I won't, that I would not claim. But that we genuinely feel that and want to be a part of that is no question. I mean, there's just simply no question. And that, and it makes it why it's so good to work here. And just in things of like what happened with the pandemic, right? So Autodesk gave all parents started in September because of the school year, right? When we realized it was gonna, continue. All parents of kids under 12 years old got up to 3 days a week that they could take off to take care of their kid 3 hours a day on the 3 days a week, so that they could take care of their kids during the school day, so that they wouldn't feel responsible that they had to finish their work and not take care of their kids. That's a value they have to do. All of us were given our bonuses. I know it's a corporate benefit and lots of people are out of work, but all of us were given our bonuses. They didn't say, well, now we need to hoard cash and we can't afford our employees. And they matched, for the first 2 months of the pandemic, they triply matched any donation we gave to any nonprofit that we believed in. And there was no like, well, you have to give to this nonprofit or this nonprofit. That if people were helping to kind of manage through the pandemic, they'd help. And then on the customer side, we also have like once a month we have a full company day off work, so that we're not sending each other emails and working. That knowing that we all need more time, because it is the struggles and the stresses that are on us every day are just so much greater than they are normally. And then on the customer side, we extended payment terms. We gave away, we extended people's licensing. So instead of saying we're giving away free software to Rainer to talk to branding, we said, well, we're extending the licensing. So you have 3 more months. So if you get a year, you'll get 15 months, right? So that people could work through the time when they might not have cash coming in. We gave, our channel partners were equipped and our salespeople were equipped with giving people much more favorable financing terms and extending the terms of our licensing. We've really been trying to figure out what is our responsibility, what can we do to make this kind of struggle. And then we did a ton of new training. So if people wanted to reskill or retool, start something new, learn a new skill, if they need to find a new job, that we could help them do that. So there's just been a tremendous kind of balance of how we're relating to our fellow employees and also how we're working with our communities across industries.
It's a beautiful case how you don't go into numbers, but into values.
Yeah,
right?
it's unbelievable. I mean, I have to say, it's not that I would have said this before, but I just read Intentional Integrity by the chief ethics officer, which I so want that job. Like, that's such a good job at Airbnb. And he talks, and Autodesk has felt this for a long time. It's kind of one of those things where you read a business book and then you pat yourself on the back like, oh yeah, we're so there. But kind of how important it is to have a mission and a vision for who we are and what we want to be in order to do a better job of helping the rest of the world.
Kat posted a question. Kat, would you like to phrase your question?
Yeah, I was just curious how Autodesk is using biomimicry, and if you are tackling climate directly, or are you doing it indirectly through products that are designed by your clients?
So we were, I'll take that question in 2 parts, right? So we were looking into biomimicry quite a bit initially. I would say, trying to remember back, I would say like 6 or 7 years ago, we were big on biomimicry. And then we came up with this idea for generative design. And what ends up happening that's so interesting is that the algorithms, when you put in the constraints and your parameters of what you're trying to design, it's unbelievable how often the answers that the computer provides look a lot like nature, right? So we were joking, the very first thing that we designed with generative design that was going to go into production was a motorcycle, the part of the motorcycle below the seat that kind of attaches to the back wheel. And it looks so much like the pelvis of a cat that it was shocking. Like, we went to like this bio store and we bought a cat pelvis and we're like, it's ridiculous how similar it was. But I wouldn't say that we go from a biomimicry standpoint. I think we go more for the programming for the AI and then the answers that it comes to, which often align with nature. And then into your second question, which is about sustainability, we have a foundation. It's actually, they get a percentage of all profits every year from the company that go directly to the foundation so that the foundation can support programs around the world, whether that's we have people in all different industries, whether it's manufacturing or construction. So as and we also are, I'm going to get all the stats wrong, but you know what Kat, I can do is I'll send you our sustainability report, but we are carbon neutral and we have, let me write it down so that, or Nikki, you can keep notes and tell me to give it to send to her. That'd be awesome. I'll send you the report because I don't want to get it wrong, but we as a company are really committed to making sure that we're thinking about sustainability, that we're thinking about climate change and the climate crisis, and making sure we're doing everything possible to support new ways of thinking and new ways of, or reinforcing ways that have already exist that are good, that need reinforcement. I don't want to say everything's all new.
And is Autodesk also part of this lead thing in architecture?
Yes, yeah. And we're also part of we've accepted and I just feel badly because I just don't know all the terminology, but the UN, that beautiful pin that has all the colors, the UN Sustainable Sustainability Goals, yeah. I just feel badly, I can't remember. I don't want to get anything wrong, but it is very important to us. And even within our software, we have, like, let's say a designer builds a building, the software will make recommendations. When you do simulations with sun studies, it'll say, well, if you turn this building by 3 degrees on the same plot of land, and here's a topographical map or whatever, we work with Esri, then your HVAC, heating, sorry for people in English, your heating, ventilation, air conditioning will be lessened because you'll be taking better advantage of the lights, the sun and the shade. And so we have that built into our software to try and create systems that then, even if the designer's not thinking about it or the construction person's not thinking about it, that the computer is thinking about it and making recommendations.
And Stephanie also has a great question.
Thank you.
Oh, there she is. Sorry.
Hi, Rama. I was really inspired by your call to change the role of computers and robotics within creativity and problem solving. And I think as a facilitator and in general problem solver, people get together, you often feel the pressure of what you don't know. And I feel like computers can really fill that role, but sort of if we all imagine ourselves at the table and our robots or our data or our computers at the table, what kind of role do you see them, or gaps do you see them filling in that collaborative moment? Are they kind of going to put the analyst hat on, or maybe a subject matter expert hat, or is it, do you imagine even an open aperture, a moment of collaboration between us and the robots where they don't wear a hat and we're just like all these kind of creative minds coming together? How do you see it?
I would say mostly I would lean toward that last option, because I think, and that's why we need to be so responsible, right? Because what's put into the computer, like I kind of said, like computers are better at facial recognition, but that's true if you're white. But the problem is what we're feeding into machine learning is we have to be so careful and so responsible about what we're feeding into machine learning to make sure that we're not relying on it as a crutch and say, well, the computer knows all the answers. We really talk about computing as a partner. So it's not seeding and saying, let's ask the computer to do this thing, but it's figuring out what are the different capabilities that the computer could have and that humans have, and how do we work together to come to solutions. So I don't like the idea, and I don't think Autodesk would say, well, let's seed whatever it is. But for something like that wheel design that we did with Briggs Automotive, which is a British company, that was that super cool looking supercar, which is street legal of all things. But anyway, they need to make it lighter. Like a supercar, how to make it faster, how to use less fuel, you just need to make it lighter. And kind of the designers, I don't want to say that they'd reached the limit of like what they could figure out how to make it lighter, but they couldn't make it lighter. And then by working in tandem with the computer and coming up and putting in the goals and parameters that are set by the designer, right? This is what we need. This is where it needs to place. These are the materials, because our generative design algorithm is such that you can even say, I want to make this out of titanium, and it'll tell you whether the design might need to change because titanium has different strengths than, stainless, or different strengths than steel, or whatever it is, right? And it'll have, or if you're going to 3D print it, the design might not work in 3D printing because you can't do something that thin, or if you're going to mold it or injection mold it, however you're going to make the product. So it seems that kind of really being able to consider what is the endpoint, what is the goal, and then figuring out what you can do with the computer to get to that goal together. I don't think it's I really don't think it's conditional if then. I really think it's a plus. Go back to like bad old school branding, like 1 + 1 = 3. Like that's what we're really looking for. Right?
And what I hear you saying is active experimentation, active engagement. And I really love that idea.
Because when you think about it, like most buildings, it's different in manufacturing. In manufacturing, you make dozens and dozens and dozens of prototypes. And now you don't need to do that. So if you're not making dozens of prototypes, 1, you're not extracting as much from the earth. 2, you're not creating as much waste. 3, you're not creating things that don't work, the second that you test them in real life, you find out they don't work. If you're able to do more of that in the computer so that throughout the whole process, you're taking less and creating more, isn't that something that we want? I mean, that to me is the benefit of working with technology, right? Is that we're able to create, honestly, make the whole process better and more efficient, and not do as much damage along the way. Because every building, if you think about it, is a prototype, right? Like unless you're building a subdivision, like with really ugly houses and they're all the same. Every time you build a new building, that's kind of a prototype. It's like, oh, is this going to work? And this is the solution. Well, how much better would it be if you can really run through the cycles of what's going to happen? How's the rain going to affect that? How's the wind going to affect that? How are we going to recollect? Is there any way that we can recollect water so that it can feed into the system so that you don't have to take more water from the groundwater to create the, the heating and ventilation? What are the different things that we can do? And to me, the opportunity to open our heads to what we couldn't have even conceived of before is what's so exciting. Because I don't think we couldn't have come up with that solution. So why not use this amplification and acceleration and opening? And I still, even though generative design has been around for like 5 years, I think that we still don't even know where it's going to take us. Like the potential that's out there is just massive.
You just mentioned architecture and building, and I think that every building is a prototype is at the same time the biggest dilemma of the building industry. And Autodesk has done a great job with simulations here and synthesis of to simulate. I think that the Shanghai Tower, maybe you'd like to share this briefly.
Oh yeah, sure. Yeah. So, and I think what most people don't know is the construction industry, the building industry accounts for 30% of all waste on the planet. That's a combination of things. They over purchase materials so that, because they have so many subcontractors, right? And you have to make sure that you have whatever you need that's there if the subcontractor can't show up. So you buy more. So it sits around. If you don't use it, you throw it away. And so when they built the Shanghai Tower in Shanghai, hence the name, it's at the time they built it, it's one of the tallest buildings. It was one of the tallest buildings in the world. It still is one of the tallest. At the time they built it, it was the tallest. And when they designed it, Shanghai has a lot of, I don't know if anybody's been there, but it has a lot of wind. It has really bad rain. Or if you like rain, it has a lot of rain. I guess not bad rain. And so they built the building in, again, would not have been possible without the help of a computer. The building has this curve into it. And by creating the curve into it, they were able to cut 24% of the building materials out of the building. So that again, 24%, that's less material from the earth, less material being shipped, and the trucking industry that creates pollution, the shipping industry that creates pollution. So using 24% fewer materials. And then they also designed it so that the building itself collected rainwater so that that could feed into the heating and ventilation of the building. They also created, to create more oxygen in the building, and again, not take as much and make energy to it. There's like, I think there are 9 two-layer parks inside the building that have trees and grass and live plants, so that again oxygenates the air in the building. And because they were able to do all the building information modeling, which is a way of thinking about the whole process of design and build, they were able to have, I don't know if any of you have done any renovation in your house. I know I have, not recently, of course, but you make a change order, the contractor's like, okay, that's going to cost you X number of dollars more. Every time you change anything, I want the light switch here, I want this there, right? And even in a home renovation project, you probably have 5, 10, 15, 20 change orders. On a building that's one of the tallest buildings in the world, there used to be like 1,500 change orders, right, over the course of building the building, because somebody didn't think about the electrical, or somebody didn't think about something, or the architect changed their mind, or whatever. The Shanghai Tower was so well designed, and they did so much simulation in advance in the building that there were fewer than 10 change orders in the entire building. And it's really a whole new way of thinking about how to build, how to be more efficient, how to have less impact on the world, and how to create better buildings. It's really, I have not seen it in person, because when I was in Shanghai, the tallest building was the Pudong Tower. But they're getting taller and taller. But it's a huge change from, there's a couple other buildings there. There's another building that by a Japanese architect, and you can see they were starting to think about using the computer for simulation. But the Shanghai Tower took it to a whole other level of really thinking about all the details and how to do it better.
I don't know if you have hard cuts, but if you have another few minutes.
Yeah, sure.
Personal question that Marcus did some research, so a different kind of architecture or career architecture. Marcus, would you like to phrase your question?
Yeah, Rana, so let's talk about career architecture. You started off with an interest in Chinese and film. And now you're talking like a sort of an architectural tech guru person interested and manic about everything to do with new tech and new ideas.
Yeah.
Now, you see, in a lot of places, people would say, well, if you study Japanese or Chinese and film, you're going to be a Chinese translator or something like that.
Yeah, sure.
Everywhere I go, when I talk about careers are mobile, fluid, and people need to have their tools to be their own architects of change.
Yes.
Autodesk creates tools to help people make things.
Thank you.
As if some of this has rubbed off on you in your own career. So what advice would you give to people who feel like, oh, I'd like to change my career? It sounds fabulous what you're doing, Rana, but I'm an architect, but I'm a whatever.
I would say two things. One, saying I know I'm coming from a place where this is not possible for everybody, right? So I grew up in the middle class, still in the middle class. I went from lower middle class to upper middle class, but I'm still in the middle class, so it's easier, and I'm well educated, so it's easier for me to say this, and I don't want to be presumptuous that anybody can do this. But at a certain level, I truly believe I am not a career-minded person. I am not somebody who has my 5-year plan, and I'm going to save this, and this is what I'm going to do, and then after I'm doing this, then I'll go right to this, and then I'll be a director, and then I'll do. I just don't think that way. I absolutely 100% believe you should continually find things that are interesting to you and pursue them. And I spent 9 years, at least, studying Chinese every day for a minimum of 4 hours a day because I thoroughly enjoyed it. I really enjoyed it. And when I went to graduate school, I was like, I love movies. I can watch a movie every single day. I love movies. I love the history of movies. I love the theory behind movies. I love lighting. I like editing. I love movies. So you know what? I'm going to do my master's degree in Chinese cinema. And UCLA nobody had ever done that before. They have the largest collection of Chinese film in their archive in the United States. Actually, one of the largest archives of Chinese film anywhere in the world outside of China. And I was like, well, they're a film school. They teach Chinese. No one's looking in their archive. Maybe they'll want somebody to look in their archive. So I approached them and I gave out a plan for what my master's degree would be like and what I would study. And they were so thrilled, honestly, that somebody was like dusting off these films that from the 1930s that were in their archive that nobody had looked at, I think, since they bought them. And I did it because I found it interesting. Really, there was no, I want to make Chinese movies, or I was like, I love Chinese, love studying Chinese, lived in Taiwan, lived in China. Now I want to study film, but I'm going to bring them together because they're both interesting to me and I'll learn something new. And so I did it. And then I just honestly have continually just selected jobs that I thought were interesting. I'm fairly smart, so I pick up on ideas and I'm enthusiastic and I'm willing to learn all the time because that to me is what life's about. So I would say just keep doing things that, if you can, it's not like I swimming in money and maybe there would have been better business decisions I could have made to be more successful and have more money so that in my next life or once I retire, I can have fun. But it's just not my approach. I live very much in the moment and can just find stuff that's interesting to me and go for it.
So Rana,
yes,
with all of this,
yes,
how come Autodesk,
yes,
with that shitty name?
I knew you weren't joking. Yes, how come Autodesk? Okay, so I worked interestingly enough, I never got a China-related job because when I started studying Chinese, this dates me in age. Thanks, Stephanie. There was nobody doing anything in China except major corporations, and I refused. I was like, I'm not working for Coca-Cola or Shell Oil or any of the other companies that are trying to figure out how to make some 1-cent widget that they can sell for 2 cents and make money. Like that's just not, I have no passion for that. Totally not interesting. So I kept getting film-related jobs. So I worked in film distribution, I worked in film acquisition, I worked in film exhibition, I worked in film production, and then I worked in visual effects. brought out the geek in me. I just find it amazing what you can do in the computer and for visual effects. And so I worked in visual effects for a number of years at a fantastic company called The Orphanage, which unfortunately has gone out of business. And it made me understand the tools behind what the artists were creating. And then the tools were made by Autodesk. And so when I had an opportunity at Autodesk to come here, I did. And I worked in the film part of the company for 5 years. And then I just started to get more geeky. And I like what the chief technology officer was doing. So I said, well, no one's doing PR for the research and the R&D department, research and development departments. Can I do that? And they're like, sure, you can do that. So I was like, okay, no one's doing it. I can do it. Like, that's a low bar to succeed at. So I did it, and I was very successful because I was super interested and super engaged. So the first feature ever in the New York Times, I was able to secure about our life sciences division, and I love doing that. And I did that for about 3 years, and then the CTO left. And I felt so connected to him, and I liked him so much, and I had so much respect for him that I was like, well, I'm going to do something else. So I went into partnerships, and I worked on partnerships. So I led the partnership with the Smithsonian Institution, and I worked in partnership with the Design Museum in London, and actually brought a robot, the woman who was in there with the robot, brought her to the opening of the Design Museum when they reopened it. It was one of the exhibits for their Fear and Love, their very first exhibit when they reopened after the renovation. And then I did that for a number of years, and I super loved it. And then I was like, we're getting a new CEO, and things are going to change, and I'm going to work on technology alliances. And so now I am in charge of our relationship with NVIDIA and our relationship with Apple as an overall company. So I don't know, I just kind of, if something's interesting, I go for it. Sometimes it works, sometimes it doesn't, but thankfully it's worked. And so far, it hasn't steered me wrong.
Thank you so much for this session. I feel like you're such an inspiration. I loved it. Thank you. It was so wonderful seeing you again. I wish I could hug you in real. I miss these connections. Social distance is a big thing.